Hi everyone, in this session we will discuss about how to model time and space, how we design time and space. So modeling or designing time and space is very much useful in case of real-time system and distributed system. So what is real-time system? Response will given within a specified time constraint. If it is does not given the if it does not give the response within the time constraint, specified time constraint, then it is not a real-time system. Generally real-time system, it will give response within a specified deadline, right? So whereas distributed system is a collection of computer, so which are physically separated and are interconnected using some network, is a distributed. So in real-time system and distributed system, so modeling designing this time and space is very crucial and very important. So this time and space concept is taken from advanced behavioral modeling. This time and space is one of the concepts of advanced behavioral modeling, which is we will do actions in we will do some advanced actions. So this is one of the concept of advanced behavioral modeling. So this time and space features includes timing mark, timing expressions, constraints, and tagged value. These all the features which is helpful for designing time and space. So first of all, the first one is timing mark. So a timing mark denotes the time at which the event occurs, right? The timing mark is denotes a timing mark which denotes the time at which the event occurs is a timing mark. So I will discuss in diagrammatically what is timing mark and what is timing expression and what is timing constraint. So the timing expression is an expression that evaluates the absolute value of time, whereas this time constraint is a semantic statement about absolute value of time. So we will discuss in a diagrammatically. So this is how we model time. In this diagram there are various events occurs. For every event we have model using timing constraints and timing expressions. If you see this Midi controller, which is just nothing but the active class, the abbreviation is of Midi is musical instrumental digital interface controller. Since this is an active class, it contains active object C. So this active object, generally active object which initiates flow of control, it send a request to test the key, test using this timing expression from that key collection. This key collection contains a lot of all the keys. So the main objective is to test each key. So this key class, this is a normal class, this is an active class. So this is a normal class. So this key will test each key which is present in the key collection. So and then this MIDI event buffer will add the key for each key. After adding into the buffer, this MIDI transmitter, which is an active class, that's why it is bolded rectangle. So it removes for every 1 millisecond, it removes the key. So this is the mechanism to test each key and add it into buffer, and after it is over we will remove the key, right? So if you see in this diagram, the C1 test keys, C2 test key, C2 add of k, all these are timing expressions, whereas the statement which is written in the flower brackets are timing constraints, right? So this inside for every 1 millisecond is a timing mark. Your execution time is less than 10 nanosecond is a timing mark. If you write in using from flower back, then it will become a timing constraint. So location. So how can we model space or a location? So we can model space or a location in two ways. One is by one is by uh, one is by adding we are placing the nesting all these elements like vision.exe, log.exe, self.exe in a server. So we are placing it in we are locating these files using Kafka server, which is present in a extra compartment. This Kafka server is a processor. This is one way of locating and designing the space. Other way of designing the space is by tagged name is equal to tagged value. Here tagged name is the location, tagged value is the router. This load agent class is present in the router. So tagged name is equal to tagged value, location is equal to router. This tagged name is equal to value is a UML extensibility mechanism, one of the UML extension mechanism. It is a timing constraint. Using this timing constraint, we can model the location or a space. So if you now the common modeling techniques. So how we model the time and space using some techniques is, one is to model timing constraints, 2 is to model distribution of objects, 3 is to model the objects that migrate. So initially, so if you want to model timing constraint, first of all, event should occur with a specified time constraint. After considering an event, then we have to consider the maximum relative time for that sequence. Then we have to consider time complexity as well. If you see, so this is the diagram for we discuss about modeling time constraint. If you see in this diagram, here the S is an object, system agent is a class, P is an object, server page is in a class, C is an object, camera is a class. You see, initially the system agent sent a request to refresh page for every 1 millisecond. This is the timing constraint for this event. Refresh this A refresh. This is the timing expression. Here is a timing constraint. Here this B of B colon get image also timing expression. After getting request from the system agent, the server page will get the image from the camera, which is the execution time is proportional to image size. So the camera will give the response to server page, which is the execution time is less than 100 nanoseconds. Then the server page will give the response to the server system agent, right? So next, modeling distribution of objects. So to model distribution of object, first of all, we have to collect the objects, identify the objects. After identifying the objects, we have to consider location for all the objects. Then we have to distribute the responsibility across the system. Then we have to allocate object in. We can allocate object in two ways. One by nesting the object, and describing adding in an extra compartment. Next, by location, by target name is equal to value. In these two ways, the location can be modeled by these two ways. One is by nesting objects in extra compartment. Next is the by using location name is equal to value, or target name is equal to value, which is a UML extensibility mechanism. If you see in this diagram, so there are objects. To model distribution of objects, first of all, we need to consider objects, and we have to we have to specify a mechanism. So if you see in this diagram, this order and sales are located. Location is workstation. This observer agent and product location is server. This product table location is data warehouse. Initially, this observer agent collect the order details from this order class, and it will collect the sales from this sales class. Then this observer agent will which is present in the server. So this observer agent add the orders and sale value into the product class. This product class contains some product. This product table contains the elements which are present in data warehouse, right? This is how we model distribute the responsibility, and we do a mechanism, right? So this is how we model distribution of objects. Next is the modeling objects that migrate. Okay, first of all, we have to consider the objects and then we have to specify location for each object. Then we have to distribute responsibility across the system. Then we can we can model the location in two ways. One by nesting objects into extra compartment. Next, by explicitly indicating the location of an object. So this is the example for modeling objects that migrate. If you say initially this itinerary class I is an object, it will send request to travel agent to calculate the minimum cost of the ticket. This travel agent, then it will move to the auctioneer, and by using the bid function, it will calculate the price of a ticket. Again, it will move from United server to SAS server. Then again, it will calculate the bid value, and calculate the ticket, and then it will move to TWA server. Then it will become auctioneer using this bid function. So then we calculate the ticket price as TWA server. Then this travel agent T. If you see, all the objects are same objects. These objects are migrating from one server to other server. So this travel agent will send the response to the itinerary. So now the topics is completed. Thank you.